Hi everyone, what's up? Today I'm going to show you how we can solve this problem up here. So this problem comes from an MIT problem set. Specifically, I got it from the 1802 SC problem set 1. So I'm going to link that in the description if you want to take a look at it. But over here, I just want to show you the solution to this problem. It's a very nice problem. It's very interesting. We're going to, the strategy we're going to use relies on vectors, okay? Which I think is really interesting to show how you can, use vectors to prove this. Okay, so yeah, let's start. So in the problem statement, in the problem set, we're given a hint, and I'm gonna use that hint. That hint says that we should think of two unit vectors that make angles theta sub 2 and theta 1 with respect to the positive x-axis, okay? So I'm gonna make a picture of that. So say we have these two vectors. We have this and we have this, okay? So these are gonna be our two vectors, and this will be, I'm gonna do that in red. Over here we'll have the positive x-axis, so this will be x, okay? Now we're going to have two angles between, with these two vectors, they will have two angles with respect to the positive x-axis. But first, let me actually label this as u hat. I'm going to say these are unit vectors. That's a piece of information that we're given by the problem as a hint. So this will be u hat and v hat. And now I'm going to say that, let's say that u hat has an angle. Should I use another color? Yeah, no, actually, yeah, I think we know what we mean. So u hat will have an angle theta 2 with respect to the positive x-axis, and v hat will have an angle theta 1, okay, with respect to the positive x-axis. So now we need to prove this, and hopefully you can connect two dots together. We're using unit vectors. That's a hint we were given. And we have a cosine over here. Hopefully, if you can visualize the dot product formula, you know that if you take the dot product of two unit vectors, you're just going to get the cosine of the angle between those two unit vectors. And now probably you see why the problem told us to use unit vectors. So, I'm going to do it like this. Notice that if you do u hat dot v hat, we're going to get the following. We have the magnitude of u times the magnitude of v times the cosine of the angle between u and v. What is the angle between u and v? Well, we know the magnitude of this. I'm going to do that in blue. We know this magnitude over here. This is kind of hard to highlight it, but yep, this angle over here, we know that will be the difference between theta 2 and theta 1, okay? So we can just subtract theta 2 from theta 1. So this will just be theta 2 minus theta 1, okay? Now, what's good about this? Well, we know this will just be 1 because it's unit vectors. Their magnitudes are going to be 1. And we're going to get the following. We're going to get that u hat dot v hat will be equal to the cosine of the angle between them, okay? So cosine of theta 2 minus theta 1. Now, this is a starting point because now we have the left-hand side of the thing we're trying to prove, which is very good. Now we just need to find some way in which we can rewrite this in terms of other pieces of information that we have. So now we're going to use the other formula that exists for the dot product between two vectors. And I'm actually just going to, do it over here real quick. I'm going to make a line here. So if you have two vectors, I'm going to say, if you're doing A1 times, A1, A2, A3 dot, let's say B1, B2, and there's a comma here, comma B3. If you want to take these dot product, well, this will be equal to a series in which you add all the vectors, you multiply the corresponding components of the two vectors. So for instance, this series, you would go from I1, I equals 1, all the way up to 3. 3 is really the number of components that you have. If you're in higher dimensions, well, this will just be the n dimensions that you have. And this will just be a sub I, b, I, okay? This is another formula, hopefully you know about this. So if we want to use this formula, well, we're going to have to find components for u hat and v hat, because this formula, it uses components. There's no way around it. So can we find components for u hat and v hat? Well, we actually can in terms of sines and cosines, and now this leads us to this nice formula here. Now, what are the components, the vertical and horizontal components of u hat and v hat? Well, so if we do this, I'm just going to make this dotted line here. This is going to be the y component of v hat. Now this is really just a right triangle, so you can just use, typical trigonometry to find this. So since v hat will have a magnitude of 1, that means that the vertical component will just simply be equal to, I'm going to say v sub y for v's vertical component. This will be equal to sine of theta 1, okay? Theta 1 is the angle between v and the x-axis, okay? So this would be the vertical, that would be the vertical component for v. And now what about, I'm just going to write it down here because I don't want to, cluster this space. So the x component for v would just simply be equal to cosine of theta 1, okay? Because the magnitude, it would just, really, you're trying to find the adjacent side of this triangle. And this is actually the unit circle. Hopefully that's something you've noticed by now. Since we're using unit vectors, that means that we have a radius of 1 all the time. If you move the vectors around, you're gonna create a circle, or at least an arc, and you will always have a radius of 1, okay? Because these are unit vectors. So this is, these components that we're getting out of here, pretty much the, same thing as the components that you get for a triangle in the unit circle, okay? So this also tells you that we're probably in the right path here. So we have Vy and Vx, and now what about Uy? So the y component of U hat, well, we know it's just going to be, again, sine of theta sub 2, and now the x component of U is going to be cosine of theta 2, okay? Theta 2, once again, is the angle between U hat and x. So now we can just simply plug these values into this formula here, okay? So I'm just going to say that u dot v is equal to cosine of theta sub 2 minus theta sub 1. And if we use this formula, well, we're going to get the following. We're going to get that we have vx, so this will be vx times u sub x plus, now we're going to have vy times u sub y, okay? And now what are these values equal to? Well, we know we're going to have vx cosine sub 1, and ux is going to be cosine sub 2, so this will be cosine sub 1 times cosine sub 2, and now hopefully you see where I'm going. And now I'm going to erase this. We have cosine sub 1, cosine sub 2 plus v sub y is equal to sine of theta 1, and u sub y is going to be sine of theta sub 2, okay? This is very nice because, well, now we just proved what we wanted to do, okay? And yeah, that's pretty much the entire solution. I think the hardest part about this problem is that you need to start somewhere, and it may not be very intuitive that, well, you have unit vectors, and you also need to find the cosine of an angle, the cosine of the difference between an angle. So, if theta 2 and theta 1 are angles with respect to positive x-axis for two vectors that are known, yeah, you can probably find the difference, the angle between those vectors, which is going to be the difference between their angles with respect to the x-axis. And then by taking the dot product, you're gonna get a cosine in here. And then by using this formula, you just, you find components, you put them together, multiply, and you get this, which, well, we just proved that cosine of these two, the difference between these two angles is equal to this, okay? Which is what we wanted to do. So yeah, that's the solution to a problem. Hopefully you found it interesting. And yeah, see you in the next video. Bye.